In this video, we want to evaluate this integral of 1 over x minus 1 times the square root of x squared minus 2x minus 3. Has a radical in the denominator, so we don't expect partial fractions. Integration by parts, don't think so. Looks like it, possibility that you might be able to use a trig substitution. But notice this has an x minus 1 here as a factor. Can rewrite this with u and let u equal to x minus 1. So always look ahead. I'm looking at this formula right here, number 3, has the integral. So these are integrals involving inverse trigonometric functions. The third one has the integral of du over u times the square root of u squared minus a squared. And it gives you the solution. So can we write that integral in that form? And that's the technique I'm going to use. If you want to stop the video here, pause the video and see if you can do it, go ahead. And then I'll be right back. So I'm going to look then at the radicand here. And I'm going to see if I can complete the square here. So we'll look at x squared minus 2x minus 3. Coefficient of the squared term is 1. So I know that if I take half of the middle term, which is negative 1, 1/2 of negative 2, and square it, I get a 1. So if this were a 1, this would be a perfect square trinomial. So let's do this. Let's just put a 1 there. But we don't want to change the expression, and we don't, and we subtract 4. That's the same thing. 1 subtract 4 is negative 3, so I haven't changed it. So now I can rewrite this. Now this is a perfect trinomial, perfect square trinomial, which factors into x minus 1 quantity squared. Now we'll go up here, and this will be dx over x minus 1. And now we rewrite the radicand as x minus 1 quantity squared minus 4. And then I'm going to use the U-substitution. Standard U-substitution. You could probably use a trig substitution. Go ahead and try it and see if you get it. But I'm going to do it this way. Let u equal to x minus 1. Then du will equal to dx. And then I just substitute here. So we're going to transform this integral into one involving the variable u instead of x. So dx is the same thing then as du. I'll put this du here. And then in the denominator, x minus 1, that is u. And under the radical, we look at the radicand here. X minus 1, that's u, so this will be u squared minus 4. So this is in the form that we wanted. At the formula we looked at, it was the integral of du over u, the square root of u squared minus a squared. So in this case, the a is equal to 2. So we can proceed then and say the integral of this expression in terms of u is going to be secant inverse, or I can write it as arc secant of absolute u over a. But in this case, a is 2. So I just put the 2 there, plus the constant of integration. And then the coefficient here is 1 over a, so this is going to be 1 over 2. Now we just substitute back to the original variable. U is x minus 1, so this is 1/2 arcsecant of absolute u, but u is x minus 1. over 2 plus your constant of integration. Thanks for watching. We'll see you next time.